Hello and welcome to this first video in a series on making your first video game with Godot 4 in 3D using C#. So this series is intended for people who have some coding knowledge, so something like C, C++, C#, Java, Python, Perl, whatever it is you might have some experience in. I'm just assuming that you have some experience writing programs, maybe just in the console, but something with like a main method and something having to do with object-oriented programming. So if you don't have that, I would definitely recommend going and maybe taking the MIT free course or something, just so you have a sense of what it's like to program. You're going to want to have a sense of what if statements are, what variables are, what type is, what type casting is, and what objects are in object-oriented programming, specifically the idea of inheritance and components and member methods and member properties, that sort of thing. Because a lot of that goes into video game programming with a game engine such as Godot. Now, I'm going to be doing this series using C#, and I'm not going to insult your intelligence by showing you how to download and unzip Godot, but I do want to just make sure if you're going to follow along and use C#, make sure to use Godot engine that's the .NET Mono version that has the C# support. So, with that out of the way, once you have Godot downloaded and opened, here's what you're going to see. And I'm assuming that this is for people who, again, have some programming knowledge but don't really know what an engine is or how to use an engine. So the best way to think about an engine and what it is and what it does, to start with, the engine is basically your main for your program or your game. So you don't have to write a main.cpp or a public static void main string args in Java. That's already taken care of for you by the engine. So what else does the engine provide? Well, the engine itself provides objects that are extendable that the engine itself knows how to interact with. And in Godot, what that is nodes. So if you think about a node in Godot, basically it's an abstract base class for any other possible node. So if we're going to add a node to this scene, you can see that the base type in this tree is a node. And you can go read the documentation on this, but this is basically what every other type of node in Godot extends. And the way the engine knows how to interact with all of these different nodes is that this particular node, if we were to add a script to it, so in our editor here, in our Godot editor, this is how we attach a script. We can see the tooltip, it says add a new or existing script to the selected node. We're just going to add a new one. I'm going to use C#. It's just going to be node. We're not actually going to use this. We're going to be deleting it. But what appears here, for me, Visual Studio 2022 pops up. And you can see that by attaching a script, Godot itself creates for us just an empty shell script that has two functions. There is a ready function and there is a process function. So ready, if we hover over, you can read it, but basically once this node is ready, once it and its subnodes in the tree have all been loaded, Godot will call ready on this node once. So this is a good place to initialize the node. For certain types of member objects, if there or other nodes, for example, if you wanted to have references to other nodes, whether they're in this node or elsewhere, you want to call that like references to that in ready. You can't do it outside. For just basic types like and floats, strings, that sort of thing. You can call it outside in the class and initialize them there. But for anything really complex, you want to do it in ready. The other basic function that is provided is process. So process, this is, you can read it, it is called basically as frequently as Godot is able to. So if we think about a game, very similar to a movie is a sequence of frames, still images. A game is basically that, but they are generated at some period of time. Now, because of differences in hardware, differences in like the processor and memory speed and how much RAM you have and your graphics card, all those different things, as well as how many tasks are running and how complicated your game is, this process is going to run at some variable frame rate. It's going to try to run at 60 frames per second, so once every 60 seconds. But if it's not able to do that, this is going to have some variation. And you can see that there's this argument double delta. What that is, as it says right here in the comment, it's the elapsed time since the previous frame. So there are times when you're going to want to know exactly how long it's been since the previous frame. You can just refer to that double delta and you will know. So basically, if you think about the game engine as your main, once it gets your game set up and it's running, it's going to go into a polling loop for all the nodes in your game, and it's going to be calling these things. Once they're ready, it's going to call ready, and then once everything's set up, then it's going to be calling process. Now there's one more that we want to talk about, and that's physics process. So this is similar to the standard process function, but this one is called and has a fixed frame rate of 60 frames per second no matter what. And the different functions that can be executed from here, they're going to have that frequency of calling. And this is done by the physics engine of the Godot engine, as opposed to process, which kind of has some more variation and variability. So it's good to put things that are really physics intensive in physics process and other things that aren't so important in process. So what would example be? Physics process is good for like collisions and movement caused by physics, that sort of thing. Process is more like handling player input and whatever else this node needs to do. So with that, let's talk about some of the other nodes that are available. So we're going to delete this and its associated script. We're just going to do a 3D scene. Now, when we're doing 3D, if you think about, well, what is in a 3D virtual scene? Well, an object in that scene will have some sort of body. So if we say, well, I want a 3D scene, well, I don't actually want that one. I'm going to do other node. Let's just make a very simple scene. So what we're going to take a look at, there's a bunch of these different things, but the most basic one is just some body. So Godot has different types of bodies. And so I'm just going to type in search body, and we can see like some of these different things that we have. There's a static body, a character body, rigid body, vehicle body, animatable body. As you can expect, static body is one that is meant to remain static, like walls and floors. So if you're going to have, say, ground in your game, you might want to use static body 3D. Static body 3D isn't moved by the engine. It's really not intended to move at all, although you can use static body for, say, like moving platforms in like a platformer game, and you can just script how they move in code. They just won't interfere with physics. Now, most of the time for your player character or for enemies who are moving around, you're probably going to use CharacterBody. So this is, like it says, a 3D physics body specialized for characters moved by script. So let's create that. And there it is. And we get a warning right away. And Godot's pretty good about saying, hey, you haven't done something yet. So the fact that we got a warning doesn't mean we've done something wrong. It's just that we haven't done something that Godot is expecting us to do in this case. So we can read it, and it says, this node has no shape. So it can't collide or interact with other objects. And as we can see, yeah, it has no shape. It's just got this sort of widget to move it around. So it gives some fixes too, and it says consider adding a collision shape 3D or a collision polygon 3D. Well, let's just do that. So we're going to right click and add a collision shape 3D, and it knows that it's going to be 3D here. So we're going to go collision shape 3D, and now we have another warning. What's that about? Well, let's read it. So a shape must be provided for collision shape 3D to function. Now, if we go here and we type in shape, well, then we don't really get a solution in here. There's another collision shape, but that's what we already added. Shape cast 3D, a shape that sweeps a region of space to detect collision object. That doesn't sound right. What we actually have to do in Godot is look over here in what's called the inspector window on the right side. So on the left side, we've got our scene view with our tree, our scene tree. And then when we click on these different things, we have stuff that pops up in the inspector on the right. Now, remember that I said all the different objects in Godot, all the different nodes, like this CharacterBody 3D and collision shape 3D, are basically object classes that extend the base node class. So in this case, these are other classes of objects that have their own member variables, their own properties, as well as their own member functions. And you can see actually what the inheritance looks like as far as properties, and we'll look at the functions in the code, but as far as properties that we have, you can see, well, these are the properties that are given by just standard node. These are the properties that node 3D gives as an extension to node. And we can see there's transforming visibility, and we'll dive into that in a minute. Then we can see that there's collision shape 3D itself, and look, there's a shape and it says empty. So that's why we don't yet have a shape. The Godot docs don't do a great job of telling you what a shape container is, but this is what it means. So it's going to talk about a character body or a physics body can have any number of shape 3D, but the shape 3Ds must be assigned to a shape container. But it doesn't really say what that is. Well, it's like a collision shape 3D is basically a shape container. So if we go here, we can see there's a bunch of different examples. For our case, we're just going to use a cube, a box shape, and there it is. Now, if we were to run the game, this is just a collider, so you're not actually going to be able to see this, but this is what Godot now thinks the shape of our body is. It's this cube. So if there were to be some other object with its own collider that this were to run into, or if we were to move the shape around through code or physics or whatever else, in this case, because it's character body, it would just be through code, then this is what is going to collide. Now, in our case, we're going to use a 3D mesh to actually make this shape visible. And that mesh is going to overlap this shape pretty much exactly. In most games that are complex, though, you're going to have meshes that themselves are not colliders. You're going to have some more basic collider like this, or a capsule. Here's an example of a capsule. Looks like that. Or something else, maybe a sphere. So it'll look like that. And then it'll just kind of fit your mesh closely, but not exactly. So, from Godot, if we ever want to run our game, I'm going to delete this node thing because that'll probably mess us up. We don't need it right now. So if we were to run our game, this says, oh, no main scene has been defined, select one. Well, we can just select current CharacterBody 3D. We'll call it player. And it's going to build the .NET project. That's just like compiling our .NET code. And then you can see our game is about to start. And we can't see anything. And there's a number of things we haven't done yet. First of all, in 3D, we need to tell Godot, here's the camera to use. And we haven't done that yet. Even if we had a camera, we would also need to give this some sort of mesh, some sort of like, hey, this is what you should actually render when you show this thing. So let's go ahead and give it a mesh. So mesh instance 3D. That sounds good. Now again, here we look over at the mesh instance is just sort of a container for a mesh. Now, in more advanced, complicated games, you're probably going to want to jump to something like Blender or download a mesh if you're not going to make your own. But for very simple things, you can make a mesh right in Godot. So we'll just add a mesh, and it just so happens that the box mesh perfectly overlaps with our collision shape mesh, or our collision shape collider. The defaults there are the same. Now let's say this is a perfectly, perfect cube, like, so it's 1 meter by 1 meter by 1 meter, I believe. So yeah, this is 1 to 1 to 1. So if we take a look at the scale, I think this is supposed to be 1 meter. So here we have our mesh cube, and we have a collision shape. And I'm going to name this player. Now, we need to do a couple of other things. Like I said earlier, right now we don't have a camera. So let's just go ahead and add a camera. Camera 3D. Now, by default, it stacks it right on top of our player. That's not really what we want. We're going to want it to kind of look at our player. There we go. Now, we can save and then play our game. And there it is. So now we can see that we have this cube, but it's this ugly kind of gray, bland color. And that's because that mesh still needs some sort of material. So we can go to the mesh instance and take a look in our inspector. And we can do this right from in the Godot editor. There's this surface material override. We haven't given it any sort of material yet. So we're going to go new standard material 3D. And we get all these different options. Now what we would like to do is just make it some sort of color. And you can take a look and you can see we don't really have a color option. We've got a vertex color, but we don't have an actual just color property. And that's because in 3D, color is referred to as albedo. And that's sort of like the underlying color of a material before light has been applied to it. So I am going to, let's see, I'm gonna, first of all, take the darkness down a little bit. I'm gonna make it kind of this like purpley color, maybe make it a little darker, and there we go. Now, there's a lot of other things you can do with this. You can change the roughness, you can change whether it's metallic or not. Those two things kind of go hand in hand together. If I were to make it really, really smooth, you can see that there's this like light that's provided just as reference. You can see what the shadows look like, you can see the shine. So if I make it 100% rough, you can't see any sort of shine. If I make it like just perfectly smooth, then you can't see it either. But with just a little bit, you can see that it's, that it makes a nice reflection and makes it like nice and glossy. Now, if I were to do metallic, it would do sort of a similar thing. You can play around with these different options. So I'm going to make it kind of shiny because that's kind of fun. Emission, and I'm not going to go through all of these, but basically this would be if you wanted like a firefly glow effect, if you had like engines or something, you can change like what the emission looks like. I'm not going to mess with that right now. I kind of like this as it is. And so let's just run this one more time. We'll see what we've got. Now, it's pretty dark, and that's because we don't have any sort of light in our scene. But that's okay for right now. So this is our player scene, and we've got our camera. Now, to play around with this and just see some other things that this can do, let's make a new scene. And the reason we're going to do that, Godot treats pretty much everything like a scene, whether it is a level or a player or an enemy, anything like that, everything is treated as its own scene. So if I make just a playground, I'm just going to say other node, and I'm just going to say node 3D actually, and I'm just going to say playground. I'm going to save that as the playground scene. Then I'm going to add a ground for our player to run around on. So what should I use as ground? Well, I'm going to go with a StaticBody 3D. I'm going to call that ground. Now we have to kind of go through the same process as before. So I have to give it a shape. So I'm going to say collision shape 3D. And then before I actually assign a collision shape, I guess I can go ahead and give it a shape now. I'll go ahead and give it a box shape, and then I'm going to add a mesh instance 3D. And I'll go ahead and say this is a new box mesh. Now what I'm going to do is take this and I'm going to go 30 by 30. Now in Godot's 3D, and this is true in many 3D editors, X and Z are flat. So X is left, right, Z is forward, back, and Y is up and down. Now I'm going to take this collision shape, and you can see these little ball tooltip or widgets, and I can make this the same size as our mesh. And there we go. Okay, now we also will need some sort of light. So let's just type in light. Let's see, directional light 3D. Directional light from a distance as from the sun. That sounds good. Whoops. So right now it's right there. I'm just going to kind of move it up and over, kind of like it where the sun. Put it over there. Sure. Put a little closer. Okay. Now, what we can do is just bring our player right in. So our player is right there. Let's move our player back. We've got our sun up there. Now, I'm going to, let's see, main scene. Let's see, scene. So I'm going to change our main scene to instead be playground. Save, and now if I run our game, You can see there's our player. Now, our player's floating, it's not falling to the ground or anything. And that's because we haven't told Godot that this player is supposed to move, that it's supposed to react to gravity. By default, CharacterBody 2D does not react to gravity. So let's go ahead and go back to our player scene and let's give it some functionality. All we're gonna do is, yeah, it inherits that. We're going to say that it's a C#, create it. Okay, so by default, create a script. It'll automatically give you like a basic character controller. So you can see there's gravity. And instead of putting everything in process, like I said before, it's putting all this physics stuff in physics process. So that's what's given to us by default. That's not too bad. Let's go ahead and save and see what happens here. So we're going to play our scene. And look at that. We fall, and we can kind of move left, right, back and forth. And if we hit space, we jump. And that's just given to us by Godot. So that's pretty cool. Now, let's say we did want some object in our scene that does react to physics. Well, let's just go ahead and play with that. We're going to add a RigidBody 3D. Let's make this one a ball. We're going to move it up here. We're going to add a child shape, collision shape 3D. We'll make that a new sphere shape. And then we also need to give it a mesh. So mesh instance 3D. We will do sphere mesh. Let's just leave it as that, sort of basic material for now. And again, if we turn off the mesh, you can see that the defaults for the sphere mesh and the sphere collider are the same. Now let's just save our scene and play and see what happens. Maximize that. So you can see we didn't have to add a script to that because it's a rigid body. And if we sort of, right now it's not reacting to physics because we're not actually telling it to do that. But if we bump into it, it stops us and we kind of slide around it if we move into it. Cool. So why don't we actually take a real quick second. What if we say, let's see, disabled. So if we disable the collision shape on the ground, what do you think will happen? Let's run our game. And we fall right through. And that's because we don't have a collider on the ground anymore. And so it's not going to react to our other colliders. So make sure to keep that on. There's other ways you can have certain objects interact with only other objects. We'll talk about that in a future video. But so we've seen these different bodies and colliders and meshes and materials. So if you want to increase your knowledge, go read the Godot documentations of those things. So read about the node, and just read the description. There's going to be a lot of description of the member properties and the member functions methods that are available, but just focus on ready and process and physics process and just the general description of node. Do the same thing for node 3D. Just take a quick look at the member methods and properties that are there. Take a read through the PhysicsBody 3D description, CharacterBody 3D, StaticBody 3D, RigidBody 3D, and Collision Shape 3D. To reinforce this, if you've been following along, on your own, make a few other shapes that can fall. Make a capsule, make a sphere, make some of these other shapes that are available. Let's see what else is available. And just kind of play with those and see what you can do. Give some different objects different materials. So give this sphere a different material, give this ground a different material, and see, just play around with the different properties of the materials and see how it affects things. And then consider, if you were making a bowling game, what shapes would you use for the ground? What shape would you use for the pins? And what shape would you use for the ball? So think about all that, do that as an exercise, and I will see you in the next